हमारा कोई और लैपटॉप या फोन है उसके अपना यूट्यूब पर सर्च करना, इससे संवाद आ देखो शुरू हो गया।
वाईफाई है ना, वाईफाई कनेक्ट हो रहा है उस लैपटॉप पर।
मेरे फोन पे तार लगा ले। और दूसरा ये क्या करते हैं, अभी है ना तुम्हारे पुराने वीडियो टेस्टिंग, ठीक है, हाँ ये वाला डिलीट कर देते हैं।
अभी आता है और क्या
हेलो, हाँ जी हाँ जी, नहीं मैं उधर चाहिए नहीं जाऊँ ये हो गया ना, हमने तो लाइक कर दिया।
चाहिए
कौन से वाले नीचे कैमरा ये लगा है, ये वाला रिकॉर्ड रूम वाला है।
नहीं हमारा करेगा ऑन सेट डाउन। आज एक काम करते हैं, बटन बंद कर देते हैं।
Sandeep is not here, so we don't have a pointer. You have to stand up. नहीं आता तो pointer. ना एक के रूम चले आप. एक के रूम से घुमा देना. हाँ हमारे साइड में बैग लगा हुआ है. हाँ वो बैग ले आ रहा है. बैग के अंदर चले वो क्या क्या पड़ा होगा तुम देखो. बैग क्या है ना.
अभी ऑप्शन आ जाएंगे यहाँ पे
वो करके सेव कर दिया,
अभी बंद कैमरा बंद हो गया।
यहाँ मारते हैं
लैपटॉप ये कौन लिखा है तो वो पड़ा एक लाइन के बाद बाकी
ये पूछता है ना रफ्तार से लगता था ना इसके बाद रफ्तार पता नहीं है नहीं बात है बोलोगे ना
तो लाइव पर नहीं करो ठीक है कोई बात नहीं आराम से आ जाओ। मैं थोड़ा बिजी हूँ थोड़ा सा आधे घंटे बाद यहाँ मार देना यहाँ कटे यहाँ ये लाइट सुन ये 2 3 4 ये लाइट बंद कर दो
जैसे और कितने आएंगे बढ़ेंगे उसको यहाँ से करें कि कितने लोग करेंगे
यहाँ से डिस्प्ले है
ये कैमरा होगा सर यही ना चालू हो चुका
इसकी विजिबिलिटी
नहीं कैमरा हुआ है
इस पे करा ये करा स्पीकर भी है ओके 2 घंटे बाद
Hello everyone, my name is Vishnu Mysore. I'm a senior manager in the Innovation Services Group with SmartChip. And very new to SmartChip, not to the Marvel company, but building within the SmartChip itself. Recently joined around almost 8 to 10 months back. I'm based out of Bangalore. Okay, so I'm based out of Bangalore and I have a team there sitting in Bangalore working with the program. we've been working on this program for the last 5 years. Today's session is about what goes on behind the scenes, at the technology center within the online program. Anyway, thank you for sharing your Friday afternoon with me. Thank you so much. I'll try to keep it a little bit technical, just a little bit technical, because that's what goes on. That's the nature of our job. Feel free to interrupt, ask questions, and then let's make it more interactive. So a little bit more about me. I've been part of the Marco Samsung family for the last 5 years. I've worked in different entities, but on the as part of the same program. I've done the master's in computer science and engineering in Texas, US, and also worked on similar programs in the US, and where we were implementing biometric-based identity and access management systems. Previously coming to Samsung Marco, worked at Line, AT&T, and big consulting firms. Anyway, let's see. For those who are wondering, yes, I'm from the city of Mysore. I grew up there. But it's not weird to have a last name as Mysore. It's pretty common. So imagine having Ghaziabad and Noida as last name. So, but it's still it's not that bad. It's been a great conversation starter. Because Mysore is a very historic heritage city, and most of the people tend to recognize it. So, it's a very common practice to have the page that you come from the master. That's how we do. Okay, we get started. Thanks for your patience. So today we're going to talk about what goes on behind the scenes from a technology perspective. I'm sure everybody has an Aadhaar number here. Just by a show of hands, how many people had a delay in getting their Aadhaar card? Like, okay, that was the problem. No, but I think it's a good. It looks like you all have a recent experience with respect to getting an Aadhaar card. Of course, we have an enrollment agency, but at the same time, we can help you to generate Aadhaar numbers since day one. So, anyway, we will talk about what the enrollment packet goes through step by step, and what are the numbers, the accuracy, and also the process and lessons learned, issues, and other things that we have come across when bringing this largest identity program. So I'm not going to tell you how to beat the system and get a second Aadhaar card. I will just tell you something about it. But I'm sure you can read the details. Alright, so just to recap on the program scope itself, the mandate has been to enroll 1.2 billion people into a biometric-based identity management system and issue unique identity numbers, okay, and provide an infrastructure that can be verified anywhere, anytime, using any type of device. Okay. So basically, what we are essentially creating is a digital identity. In the next day, also, we touched upon what a digital identity is, and I think everybody being online, digital identity is really a lot of prominence. So Aadhaar is actually Aadhaar number is actually a digital identity. Because you can use it online. You can there is no card actually that the card that is issued, but it's not like an ID card that can be used purely based on the card itself. Ultimately the value is in the verification of the card, okay, of the number against the biometrics of the person. Okay? So in that sense, it's purely a number tied to a biometric, and you can carry it carry it with you anywhere as long as you're afraid and you know the number. You can carry it online anywhere, and then there is an ecosystem that is built around it using open APIs, and a lot of the applications are being built, right? So attendance systems to digital authors, e-command, to come across some of these things as we speak. So that's the scope. I'm sure you must have heard from previous sessions as well. So we will move on. Just to look at the progress, right? The program was launched in 2010 September. Okay. The first 10 million Aadhaar numbers, it took us 270 days. Right? The next 10 million actually just took 35 days. And the subsequent 10 million, 24 days. Okay, and then since then onwards, we've been doing 10 million in 10 days. Right now, we're doing 1 million Aadhaar generation on a daily basis. Of course, there are ups and downs, depending on the enrollment rate, system issues, and other things. But in general, the capability exists there for 1 million. So, and we are on track to, the current numbers are 85 crores, and we are on track to issue 1 billion Aadhaars by the end of this year. Okay, I think that just shows the kind of map out that has been done. So they always say, right, the first million is the hardest million, right? So just like that, the first 10 million has been the hardest one. This shows the timeline, right? So pretty well, and then the last 4.5 years, it's been keeping our own secrets of where we want to get. So also at the same time, you ramp up the infrastructure, you use this number, okay, where the system will support the authentication using the biometrics has been put in place. 100 million authentications using the system, and a lot of interest and evangelism going on with respect to making Aadhaar an online identity platform for pretty much everything that you can conceive, okay? In terms of an application. So that is definitely going to So during this process, just some numbers. There have been 10 POCs that have been done, right from validating the multi-modality concept to finger authentication, iris authentication, and human enrollment. All kinds of POCs have been done, wherein the lessons have been taken and put into the actual system. 3 pilots have been done. There are right now 28 plus enrollment stations, 87,000 operators, and with respect to the Aadhaar itself, 850 million. Actually, assuming that you were very productive from day one, that translates to around 500K Aadhaar. As I said, we did 1.5 million as well, but just in general, the average translates to 500,000. And the capacity exists to go along for. So let's take a look at the ecosystem component, right? So the Aadhaar ecosystem actually comprises of 4 things. There's an identity engine, okay, that plays the main role in Aadhaar issuance, okay, wherein there's enrollment going on, biometric unification, the Aadhaar generation, and all the associated processes, are part of this engine. Okay. Then there's an identity store, okay, that actually houses the demographic data, your biometric data, and then we have some interfaces, that can be connected through the web, that exposes them for updating your address information, your phone numbers, your biometrics. So that's the identity store component. Okay. Then there are services built around it that are exposed by the Aadhaar ecosystem, okay, wherein authentication is a service through OTP or biometric, eKYC. For example, the biometric analytics that all of you do on a daily basis, that's part of the identity services. Okay. So the best finger detection, that's another service that helps you know which is your best finger, okay, to be used for authentication. And then the identity apps, which is basically the ecosystem of apps that everybody is using, that can drive the digital identity concept across the media. So each start we come on, all these are part of the identity apps. So again, this is talking from my experience, right? So this is how all the envisioning of the system started, right? So we need to have these many components, right? This is how we approach building this large scale system. So today we're going to talk about this identity engine, okay, because that's the one that is mostly unknown to most of the people, and has been the key driver for the rest of the components. So that comes first. So some of the architecture guidelines, for those who are technical, pretty sure that it's fairly understandable. But bear with me on this for those who are not technical. Some of the concepts are fairly common sense. Okay, when you're building a largest system, especially at the national level, right? Right from day one, there is a general agreement that okay, we don't want to be marketing to a particular vendor. Okay, we don't want to be, we want to be using open standards, open platforms, Linux. These are the kind of things that everybody was talking. Right? And they were straight away incorporated into the architecture guidelines. Okay, so for example, the hardware that we use, there are all kinds of hardware, vendors. There are, HP, IBM, you bring in any machine into the, into the data center and it will work. Okay, so those were the guidelines that were actually adopted when we were building this whole system. Okay, and of course, it has to work with any device, whether it's a desktop-based device or whether it's a mobile device. Those were kind of concepts, guidelines that were adopted when building the system. Okay. And then, of course, nobody had done this for a billion people. So everything that we had to do had to scale to billions of numbers, on a daily basis, on a large scale basis. So the scaling was the biggest concern, whether from a biological algorithm perspective, whether from a storage or server perspective, scaling was the biggest concern that we had to address from data. Okay? So those were taken into consideration when we built the system. There were multiple locations that share workload, multiple locations that actually provide the redundancy. These are the concepts that were taken into consideration. And security and privacy, that's the biggest concern when we deal with identity management systems, especially when you're storing biometrics. Right? So, and especially Aadhaar program was such a PR nightmare, right? When, everybody asking questions about what happens to my identity, what happens to my biometrics, what if someone steals biometrics. There are companies, CIA companies working as part of the biometrics. So all kinds of questions like that. So we had to ensure that the architecture, the security practices meet world-class standards, and the data privacy guidelines are followed. So also when it comes to managing the enrollment packets, right? The approach was fairly simple. It's like assembly line. The packet comes in, the enrollment packet comes in, it gets processed, and then it just goes out. There's no there's no mix and match. You feed a stream of packets. It gets processed based on a concept called state-driven architecture. It sounds exotic, but basically, there's a those who are technical, it's very easy to understand. There's a packet, and then there are various standard streams. Okay, as and when it moves across multiple parts of the assembly line, it gets a check mark. Okay, saying that I'm completed validation. For example, the first thing that happens when the enrollment packet is fed into the Aadhaar data center, goes to the packet structure validation. What it means is that there's a program running that takes the packet and checks whether it conforms to the standards that are defined by UIDAI. Okay, so it's and then this packet gets a check mark saying that I've completed this process. The next goes to demographic data validation. Okay? So UIDAI employs some fuzzy logic to make sure that the demographics are properly spread out, the first and last name are separated, and then the zip codes are proper. They are as per the India Post formats. So these are the kind of things that actually goes to the demographic data validation. Okay? And then operator verification, which is basically OSI stands for operator, supervisor, and user verification. So every packet, every enrollment, right? When you do an enrollment, your operator will have put their finger to actually to tell to mark, to sign off saying that this is green work on the enrollment. So those kind of validations go apply on the packet. And then the biometric duplication and the eventually the Aadhaar number verification. So the concept here is that yes, we are dealing with the 1 billion plus enrollments, but the the underlying concept is very simple. That you move the packet to a fairly simple, stages of validation, unification, and all application. So this is the sort of big picture. On another sort of shows what all the things that goes on behind the scenes, right? Stage. So these are all the enrollment stations. So these are all the enrollment stations that feed the data, they feed the enrollment packets into the UID data center. Okay? So usually these enrollment packets come to an SFTP upload. When you upload your package, and you bring the hard disks which have enrollment packets into UID data center, and usually they are copied into the staging area. Okay? So the enrollment packets, each packet is around 3 to 5 MB. Per packet is 3 MB to 5 MB, depending on how many attempts have been put into the system, have wanted to be enrolled. Okay. So all these are extracted and stored in a data store. Okay. So again, when I say data store, it's actually the database because of the size of the data that we are managing. Gloria has used big data technologies. This talks about Hadoop, HDFS, a little bit. It's something that we usually very small projects don't come across these kind of technologies. Okay? So anyway, so the packets are fed into our store, okay, the data store. All right, then there are a sequence of steps that goes on. Okay, as I said, first the data structure, the packet structure validation. Next is demographic validation, and then the operator verification, and then the biometric verification. This is where the fingerprints are compared against the rest of the residents. Irises are compared against the rest of the residents, and eventually, if no duplicate is found, then another will be generated for that. Okay, otherwise it is equal. Okay. So, and then of course, when there are analytics and business intelligence softwares that are running that help in reward creation, fraud management, and few other aspects of the program. So I will get into a little bit more details later on, but any particular questions on this? Again, as I said, the number of stages are very simple. The packet goes through once it is uploaded, it goes through just 4 or 5 steps to actually before getting generating an Aadhaar. So just to talk about the scale, okay? So it's like the original target was 600 billion, 60 crore in 4 years, but we have done 850 billion in 4.5 years, and the daily capacity is 1 billion per day. That actually translates to 850 billion biometric matches. Okay, I mean just let it simply for a minute, but it's 850 billion matches. Because that's the number of matching that you have to do to ensure that an enrollment or a resident is not duplicated. Right? That's what happens. As I mentioned, average packet size is 3.5 MB. Okay, so imagine 80 crore into 3.5 MB. So that plus some other data and whatnot. Okay, so roughly we have around 10, 12 petabytes, which is basically encrypted using very highest standards encryption. So 12 petabytes, just to give you guys a comparison, I think Facebook, roughly around last year it was around 50 petabytes. So when we are handling actually it's 10 petabytes. So we are handling more than the size of the Facebook, what Facebook maintains in their data centers. Of course, I'm sure everybody uploading their images and whatnot into the Facebook, they're going to overtake us very soon. But just to give an idea, I mean, that's the kind of scale that we need when it comes to data management. Okay? And the I/O that goes on within the system is around 30 terabytes. These are some numbers that are really hard to grasp because we don't come across these numbers on a daily basis. But they are very, very huge and has profound implication for the infrastructure. And we have multiple data sites, data centers where data is replicated from one side to the other side. So all kinds of again, there's so much data that's being collected. Every enrollment, the time it takes to do an enrollment, the quality of the device, the quality of the enrollment package, all kinds of data is being collected. It's a gold mine for people who are doing data mining and other business individuals. Okay, so now a little bit more interesting part about the biometric innovations itself. Basically, as I said, this is the largest biometric database in the world. Right? Nobody, the next biggest is Indonesia, which is like 17 crore, and the third one is the FBI, which is around 15 crore. So, I mean, the scale is, it's really it's many times more. Okay? So, what the idea did was, since the biometrics, nobody was sure whether biometrics can scale up to 1 million. Okay? So what they did was they said, okay, let's not stick to one vendor, one biometric engine. Okay, let's get 3 biometric engines, with their own algorithms and systems. Okay, and then let's put them into some sort of a competition so that everybody can do the best and we get the best system out of the whole thing. Okay? So, basically there are 3 vendors, not just smartphone. Okay, there is L1 identity systems and NEC. So the NEC is one of our main competitors. Okay, so there are 3 vendors who are put in to set up their biometric unification engines. Okay? So, of course, smartphone has done the maximum. They the number 1 system. We have UIL issue. The first ADA, the 10th ADA, and also the maximum number of ADAs have been issued using the smartphone system. Anyway, so we'll get into how the biometric 3 vendor concept works. Okay. So, when you are doing biometric unification, unification is the process of finding out whether a duplicate exists or not for a particular person based on fingerprint, iris. Okay. So when you are doing unification, first the enrollment packet is sent to all 3 vendors. Okay. So this one, this 2, this 3, the enrollment packet is sent to all 3 vendors. Okay. And each of them, creates templates out of these packets and then inserts into their database. Okay. So, one of the key requirements here is that the enrollment packet has to be inserted into all 3 systems. Okay. So, because there are some, I'll tell you why. Okay. this slide, but until enrollment packet is inserted into all three systems, it won't take process. But once it is inserted into the enrollment system, then a unification request will be sent to all these systems, to one of these systems. Okay. So basically there is something called dynamic allocation, okay, wherein the unification request is sent to either one of the systems, one of the biometric engines. Okay. So the dynamic allocation is based on a ranking system. Okay. What UIDAI wanted to do was to actually promote, reward the best and the most accurate system. Okay. So the best system is measured in terms of accuracy, performance, and hardware footprint. Okay. So let's say if there is a biometric engine that is just running on 100 servers and it is very accurate and it can do 10,000 per hour, then that gets the highest number rather than a system that takes 200 servers can only process 500 verifications. So there is an allocation system that is built by UIDAI, and based on that, they set the percentage saying that okay, this one gets 50%, verification request, ABC gets 30%, and ABC gets 20%. Okay? So, for based on this logic, the biometric engines get various get to process various number of verifications. Okay? The reason is that UIDAI pays the biometric vendors per verification. So basically, the more you do, the more you get, the more money you get. So obviously, this sort of concept promotes and rewards the best biometric. And as I said, Marfo has done the most, which means that we are the number one out of these three vendors. Okay. All right. I think UIDAI takes very high pride in talking about this system because of course there was no vendor market because they have three options. Even if one of the vendors says okay, I'm not going to be part of the program, they still have other two vendors to rely on. Okay, so this greatly mitigates any risk for the program itself, and also in terms of algorithms and technology, so they have three options because earlier nobody had done this and they were not sure whether the system is scalable or not. Okay? So they took this approach to actually mitigate a lot of the risks, avoid vendor blocking, and also reward the best in this vendor. Okay? So the next we talk about the authentication, which is basically what's happening right now, right? We have crossed a critical mass of where there's a lot of focus on authentication requests. I'm using Aadhaar for authentication purposes. So some of the numbers, basically right now UIDAI is supporting finger and iris for authentication as authentication modalities, biometrics, OTP as well, based on the number of phone numbers that we have. Right now, the system is capable of processing 100 billion authentications, okay, which is in 10 hours, that is 10 billion per hour. So this is really amazing numbers. Actually, 10 billion authentications per hour is just a huge number. Okay, and it's some additional numbers with respect to the type of audit hours and it's being generated on a daily basis. Okay, a very high level architecture. I won't get too details into it, but I'll get straight into some of these. But basically, there are multiple sites because the authentication requests will be coming over from all over the country. UIDAI is planning to have multiple sites that would have this sort of architecture, wherein they will replicate the data as multiple data centers and able to meet the 10 million per hour throughput requirement. So, some of the concepts the technologies are really latest. Right. So system stack, this is the larger list of technologies and systems that have been used. You can see right from most of them are open source. Big data technologies. One of the things is, as I said, the entire, since the organizing large amounts of data, the use of database itself is very occasionally they use database, but everything is file system based. Even our engines are file system based, meaning there is no more database within the system. We have 85 crore templates, which means that we have 80 crore files within an operating system. The Linux is capable of handling so many data files, and that's what we are using for the some hardware infrastructure right now. What's being used at UIDI? Right now, UIDI has 5,000 servers. That roughly translates to 128,000 CPU cores. Memory of 334 terabytes for physical level, and the data centers are 7,000 square feet each. And number of files is, as I said, 10 billion files are being managed. Our own MPSS, which is the parametric engine, which has a pair of 4 lines, 6 lines. Okay. And then we have the MPSS is currently running on 750 servers. That's one system, one application running on 700 plus servers. Okay. And the number of inserts that can be done is 2 million per day. Just even within the Morpho, there is no way. Usually one of the practices is that whenever you deploy software at the customer side, you will test the system, right? But within Morpho, there is no such infrastructure to test this. Every time we go and deploy something software update, we say it has to be very carefully planned because there is no way to test an upgrade how it reacts on a 700 system or with a 85 core template value. So it's a very carefully managed process, which is done. So, as I said, this is the largest parametric project in the world, and the biggest IT project. Data management challenges are similar to Facebook, and kind of planning and work that has gone into key at the stage is enormous. All right. Just to give a quick, view into how do we monitor the system? Okay? This is what an actual monitoring system looks like behind the scenes. Okay, so this would actually be around the assembly line concept. Okay, so this part of the screen indicates how many packets are being uploaded. This part indicates how many are being going through the demographic validation. What is side? This is the ABS part. Okay, so you can see 3 ABS. That's why you see 3 lines actually, right? And then this indicates how many hours have been generated. Okay, so senior management can walk in, just take a look at this dashboard and say, okay, I know what's happening. Where the blocks are, where blocks are, what minutes are, and how many hours have been generated per day. It's pretty cool. This entire snapshot of the system. Real time. this is based on HTML5, and it keeps refreshing again and again to really up-to-date data, up-to-date information on what's going on with respect to the enrollment packets that are being coming in and how they are being processed. Okay. So data quality, and I just wanted to share some statistics of what we see behind the scenes. Okay? So, the program itself, it's an inclusive program. Means everybody should have an Aadhaar number. Every resident should have an Aadhaar number. Okay, and there should be zero, failure to enroll. P means failure to enroll. Everyone should be enrolled into the system. Right? But we see, we do see some enrollment failures, right? For whatever reasons, people don't have fingerprints or iris. People don't have both, or somehow, they're not provided it. Okay, but so there is 0.14% of people without fingerprint and iris within the system, which means that roughly translates to around 1 lakh people, 1.2 lakh people out of 85 crore. 1.2 lakh people don't have fingerprint or iris within the Aadhaar system. Okay. You might be asking how do they authenticate? That's, I don't know. We have to observe their face. They will have enrolled in their face. So maybe one of the case to introduce face authentication in the future is for these kind of people. Okay? Who don't have either finger or iris. The quality of the fingerprints and iris, so both fingerprint iris are so low, poor quality iris, has been only 0.23%, which is actually not bad for such a large scale system. Roughly around 2 lakh people have such a low quality fingerprint of iris that they cannot be easily matched. So that's a pretty small number. But when it comes to poor quality of only one modality, either fingerprint or iris, that's the number. You see, 3.9% people have very poor fingerprint quality. 3.94% actually translates to around 3-4 people. Okay? 3-4 people have poor fingerprint, but they have good iris. That's the kind of numbers that we're looking at. Iris 7%. Okay, which means it is very high because iris capture is actually dependent on the camera and quality and other things. But it's still around quite high. Face is around 9%. The reason I'm sure most of you is everybody that I know always wants to change their photo or the ID, right? So usually the face has the lowest quality because it's being captured with webcams, cameras like this using large scale cameras, very poor quality webcams have been used to capture face. That's why the high rate of quality issues. So, key takeaway from this data quality, what we have seen at UIDI is that using both finger and iris actually helps to be more inclusive when it comes to enrolling people. Most people will either have one of the modalities. Okay? So it will help to improve the inclusiveness of the system by taking these factors. Data quality is comparable to Western countries. This surprises a lot of people. Okay, because one of the notions when the program started was that India is full of labor-oriented, manual labor-oriented residents. Who are either working in farms, fields, whose fingerprints have been worn out. Damage, right? But surprisingly, that was not the case. 85 crore, we reached a point where we can confidently say that, by the way, Indian fingerprints are quite okay. I think that's one of the surprising, lessons that we learned, that fingerprints don't wear away so easily. But of course, it wears. But the fingerprint, it's not as bad as someone would have expected or predicted. Good biometrics for children. Okay, usually the fingerprints. When it comes to biometrics, iris modalities are pretty stable. After 2 years or so, after 60 to 80 months, of your birth, the iris becomes stable. Right? It doesn't change after that. But fingerprints, as you grow, the fingerprints keep expanding. As your fingers become larger, the fingerprints keep changing until 9 to 10 years. After that, they become quite stable. But the biometric engines have improved so much that they can actually compensate for this this growth. They actually scale the fingerprint and still achieve a quality that is manageable, that can be taught as a beautification process. For example, what I mean is, let's say there is a kid at 6 years old, right? And there's an Aadhaar number right now. 3 years later, if the kid comes back and enrolls, we're very confident that we can catch. We can catch the enrollment saying that, okay, this person has been issued a biometric, an Aadhaar number already. So the quality is also quite good enough to actually manage that aspect. But the most difficult part when it comes to data quality has been the serial population. Who actually had we had in terms of the quality of the data that we've seen, the quality has been really bad for the older people, either because they're not putting enough pressure, they have actually worn out over the years, and two other reasons. So, any questions around it? But that's, I really think that's quite interesting, because after doing 85 course, a lot of the myths, portions that we have had against Indian population actually get busted up based on these numbers. Okay, all right. So a little bit more about accuracy itself. When I was telling the Kapil earlier that I'm not going to teach how to beat the system, and get to Aadhaar numbers. So just to show, all right, the system is not perfect. Okay, biometrics is a probabilistic science. Okay, it works on the probability of a match or a non-match. Okay, so it's a balance that we have to make when we're doing the system. So there are usually the biometric systems are measured in 2 ways. Okay? False negative identification rate, and start off with false negative means you fail to identify a duplicate, a genuinely duplicate enrollment. Okay? So it leads to duplicate cards, right? And that rate is 0.1%, which means out of 85 crores, roughly around 85,000 to 1 lakh duplicate cards are out there. I'm sure, again, I don't know if anybody knows someone else having 2 cards, but we know for sure that at least there are 1 lakh cards duplicate ID and other numbers have been issued by the system. Okay, but it's still fairly good, for a civilian system. We've seen a lot of government agencies coming in and saying, okay, look, your system is not perfect. You have 100,000 duplicate cards, but it's still better than having 20% leakage, to the previous system, right? 0.1% is any day better than 20% leakage that duplicates that we see in public distribution systems, in gas agencies. I think that number is very, very small compared to these numbers. So the second accuracy measurement is false positive identification rate, which is basically, if you identify, if the system says that, hey, by the way, these two packets seem to be a match, but that we determine that they're actually two different people. That question. So we actually determine that two different people. So that's also part of the system. Usually, if you do 1 million enrollments on a daily basis, we see 3,000 such false hits, wherein the system says, hey, take a look at these two records, they seem to be similar. Okay, because one of the IRC is similar, two fingerprints seem similar, then the system says, okay, take a look at these records. So usually they go through an authentication process where it's a manual process. Someone looks at both the records, checks their demographics, checks the faces, and says, okay, they are different, they're same, then the issues are other. So again, some of the key details is that using both finger and iris was a very good choice because it helps to achieve very high accuracy and compensate for some of the operational issues that we see. Okay. Right. So I'm going to share some few issues that that we encountered over the last few years. So this is a good quality and correct iris. Okay, this is how an iris capture looks like. Okay, so usually when you do an iris capture, the data comes with a label next to it. Okay, so the label says right eye, and you see this is the right eye because here that is on the right side, which is next to the nose. But sometimes what we get from the field, we do not is like this. Okay, people, there are many devices that actually you can hold them upside down. Then it's a bad ergonomic design. But this is the way you are supposed to hold it. But sometimes people hold it like this. Okay, RS operators hold it like this. Okay, so the capture will still go, but the label says right eye, but this comes to the left eye. Okay, so the way system works, don't tell this to anybody, but the way system works is that the right eyes are compared against all the right eyes in the system. Okay, at least this is what we used to do earlier when we started. Okay, you compare the right eye of the incoming packet against all the residents that are enrolled on it, that have the Aadhaar number issue. So today, if I go and enroll myself, my right eye will be compared against all the right eyes, all the 85 crore right eyes that are in the system. Okay, and the left eye are compared with the left eye of the 85 crore people. Similarly, the left slab, okay, the right slab, the thumbs, they are all position-based matching. Okay, of course, if you can compare right eyes versus all the eyes in the system, right, left, or your left slab against right slab, left slab, thumbs, you can compare against all. Nothing is preventing us from doing it, but it's just that it takes 10 times more computing power to actually make that happen. So right now we are running on 700 servers, but if someone says tomorrow that, hey guys, start comparing against all the modalities that you enrolled, then you would need 7,000 servers to make to make that happen, and still need still process 1 million per day. Okay, so it's a trade-off that we have had, wherein we compare against right eye to left eye. Okay? But anyway, I can see some people are already getting some ideas, right? But what we did, okay, this is what we used to do earlier, okay, but later on what we did was that we started rotating the template, okay, and then searching it, okay. So what happens is, this template gets rotated, okay, and then searched against, again, not against the right eye, the left eye, against the left eye, right eye only, but it gets rotated so that we can catch some sort of these issues. So It takes a little bit more processing power, but at least something that we could afford. So, this doesn't actually get out there. So another set that we encountered, during the these stages. So this is the correct eye. Okay? This is labeled right eye. The ear duct is on the right side. Okay. This is also labeled as right eye. Okay. This is the kind of data that we started getting from the field. Okay. But if you look, the KLM is on the left side. Okay. So what happens is, these eyes won't match. When you try to match, they look very similar, but some of these features, they won't match. So this was an issue because of an enrollment device. There's a vendor called Project. Okay, they have this enrollment device. So what happened was they messed up. Now their firmware started writing the pixels from this is usually you create a picture. The pixels are written from left to right. Okay, but they started writing from right to left. Okay, so what happens is all the features get transferred to the right, and vice versa. So what happens is usually the iris, this is how the iris looks like that. So some of these features are compared, but when you change the way you write it in the image file, everything is shifted. So we started getting a lot of false negatives, meaning that we are not catching people, because of these issues. So ultimately, these kind of issues were fixed. Updated firmware and other things on the field. So these are the things that we came on. Right? So then there is another interesting issue. This was very interesting because back then Dr. Manmohan Singh was the Prime Minister, and the PMO actually started calling us. With this issue called turbulent issue. So during the improvement of the phase is also captured, right? So what happens is that there's a quality feedback given during the enrollment. So wherein we have an SDK that says whether the phase capture is okay or not okay, and then based on that, you initiate one more attempt. Okay? So usually there are 4 attempts, and you go through all the 4 attempts. If the quality is not good, then you go through 4 attempts, and finally the system says, okay, 4 attempts are enough. Then you move on to the next figure capture, iris capture. So what we used to do was take from the camera itself, the image comes like this. Then we use the SDK to crop it, okay, and then do a quality check. Okay, the quality check is based on ICAO standards. Remember, if you go to passport office, they say it has to be certain size, length, and all those things. So those are the kind of quality checks. So what used to happen is everybody in Punjab started getting everybody had to sit through 4 attempts, because the enrollment file kept saying, okay, no, not good enough, not good enough, not good enough. And someone in the state complained to the PMO office saying that there's some discrimination going on against people from the state of Punjab. And suddenly they're getting calls saying that why is this not happening? So again, it's an adjustment that we had to make, but we didn't anticipate such kind of issues because India is such a diverse nation. So so later what we did was we actually applied the quality checks on the original capture before copying it, and then we copy it. Basically, this is the one that gets printed on the card. Okay, so that's why we were doing it earlier. So that way, then we have to change it. So these are the numerous kind of adjustments that we have to make to fit the Indian demographic needs. Okay? And I'm sure you have seen all these issues, right? So actually the first one is actually was a goof up, not by us, not by Monster, okay, but by someone within UIDI, okay. Simple mistake, right? So Usually, as I said, the four captures. There are four captures that happen as part of the loading. And sometimes the operators are like they want to test it, they can, they simply point to something and take a picture. They might have done it for also. Okay? And the enrollment, our Morpho SDK provides the capability to determine whether there is a face within the picture or not. Okay? So there is something called face test, and it's a score given to a particular photo. So there are four, especially in this account, for this particular account, there were 4 attempts. Okay? The first one was a dark picture, and the 3 remaining were proper person images. I've seen the pattern, okay? But when you print the card, okay, when you send the data to print the card, the practice is to pick the photo which has the highest faces. Okay? Basically because there's a high chance that there's a face. Okay? Right? Someone actually did, based on the descending versus ascending, programming mistake. Okay, instead of sending the highest, they send the lowest. So there was a period of time when people were getting pictures printed with the lowest faces. Okay. The second one, okay, that's another clear night. There was nothing wrong with it. It was purely a enrollment operator. Someone started enrolling God's name, okay? Trying to praying that they will get answer. But the way biometrics works, right? As I said, it's probabilistic science. Especially in case like this, of course, Hanuman is God, and basically the way it works is in face recognition, it tries to detect the eyes and the distance between the eyes and the structure of the face, and makes an assumption, okay, it's a score saying that this is the face. Okay? That is a face. Someone echoed, the face of the God, and the system said, okay, it's good, right? So there's nothing that we could do on that front, but this was definitely not something that was a so there are similar other incidents and experiences that we have gone through. Some are, as I said, mostly it's been learning exercise, doing exercise, but otherwise, I think as a system, as a citizen of India, right? I think I'm very proud of the way things have been done with respect to the system, because let me take away the Morpho CAT for a while, but if you look at the way things have been executed in the Aadhaar program, it's a very, very big program. I've worked with officials, right from the topmost officials to all the way to the people on the field. It's a very clean organization, very dedicated organization, very, very hardworking, very transparent. Of course, there are bureaucratic red tape, red tapeism across. There's still at the end of the day, it's still a government organization. Not a single person cannot take a decision. Everything has to be approved by a committee, and then the payments are delayed. And almost maximum penalties. But again, at the end of the day, it's a very clean organization trying to do the best for the country, and exercises that has gone through, coming up with this has been tremendous. I think my parting words are about how technology can be used to actually make an impact on this for 1.2 billion people. Aadhaar is such a great example of it. So that's pretty much what I had for today. Thank you for bearing with me. It's been, as I said, this is my first interaction with a much larger audience within this market. And I still have a lot more things to share and before going to the blog. But thanks for giving me an opportunity. Here's my contact details if you have any questions or would like to know a little bit more. Thank you for staying yeah. We don't have a coordinator, but this one can tell us what the next steps are. But any questions, actually?